3.1. And the topic is derivative. The word derivative really means the slope of the tangent line. The slope of the tangent line. And we'll show you how we're going to find the derivative there. Now, if I have this problem, or this picture, the graph, and I said to you, what's the derivative here at this point? You go, well, the derivative is the slope of the tangent line. What's a tangent line? A line that touches the graph at one point here. That's the slope of that line. What's the derivative here at this point? That's the slope of this tangent line. So the derivative means the slope of the tangent line. Now, if my graph looks like this, let's say something like this, what's the derivative at this point? Is the slope of that tangent line. Is that positive or negative, the slope? Positive. What's the derivative here? The slope of this tangent line. What's the slope there?
There's no slope.
0, right? What's the derivative here? It's the slope of this tangent line.
It's negative.
That's a negative. So your derivative could be positive, could be 0, could be negative. Now, how are we going to find the slope of this line? Let's say I want to find the slope of that tangent line. Let me draw a couple of pictures here and show you where the definition came from. I'll just enlarge the picture again. If I want to find the slope at this point, what I might do, take a couple of points, one before and one after. Maybe I'll take this point, this point. This is the x value, and this will be what? F of x. If I call the gap between this and that delta x, so this value will be what? X plus delta x. And what's the y value here? That's f of x plus delta x. This is the tangent line here. A lot of times what I might do is actually find the slope of the line that connects these 2 points and use that as my answer. So if I connect these 2 points and I use the slope of that green line, what's the slope of that? The slope is going to be what? The rise over the run, right? Which is what? It's going to be f of x plus delta x minus f of x divided by the run, which is what? What's the gap from here to there? Isn't that delta x? But you can see the red line and the green line is not really the same line. And it gets worse if I pick 2 points far away from each other. Same picture. I want to find the slope here, the slope of this tangent line. And if I wasn't paying attention, so you know what? I'm going to pick this point. Let's even go higher. I'm going to pick this point and this point. And I'm going to approximate the slope with this line. That's not good. They're too far away from each other. The best thing you can do is get close to these points, to that point. If you get close to it, your approximation, which is the slope of that green line and the red line, will be almost the same. So notice if I get close to that, I'll do one more picture. And I want to find the slope of this red line here. And I pick 2 points here, close to it, and connect them with the green line. I don't know if you can see the green. Notice the green and the red is almost the same line now. This is delta x. This is f of x. F of x plus delta x. Ideally, you want these 2 points to be what? Right on top of each other. That's why the definition of the derivative, which is the slope of the tangent line, if you want to use the approximation, it is actually the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. It says pick 2 points right next to each other. The difference between them is almost 0. Then the green line, if you can see the green, the red line will be the same line. And that's where that definition came from.
So delta x is the really small.
Delta x is the gap between this point and that point. And you want that gap to be very small, almost 0. Yes?
Why can't you just pick 2 points on the tangent line if you want to find the slope?
Pick 2 points. Well, you don't know what that tangent line. You're trying to find it, right?
Yeah.
Because you're trying to find the slope of that tangent line. So we have no idea what that line is. So, and here's actually our book, probably with pictures. They probably do a better job than me. Let me see if they do have it, like multiple pictures with different colors. No, actually, they did the same thing as I did. They did actually make, I don't know if you can see it. I don't know if you can see it. See, they made the delta x big here, smaller, 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 then the 2 lines become almost the same. So the definition of the tangent line with the slope m is the limit as delta x approaches 0. Here they wanted at point C, that's why they use C. They're giving you a specific point. I'm just giving you the equation for any point. It's f of x plus delta x minus f of x divided by delta x. Okay. Now, I did a little bit different than the book. Here's the question in the book. Find the slope of the graph of f of x equals 2x minus 3 at the point 2 and 1. We want the slope as x close to 2 approaches 2 here. Now, me personally, I just showed you how to find the slope of the line. I said the slope m is going to be the limit as delta x approaches 0 of f of x plus delta x minus f of x, the whole thing divided by delta x. That's what I'm going to use. I call this the 4-step process, sometimes 4 plus. The reason I call it the 4-step process because the first step I'm going to find what is f of x plus delta x. What do we do here? We go to this function, replace x with what? X plus delta x. And what do we have? 2x plus 2 delta x minus the 3. Step number 2. Find f of x plus delta x minus f of x. We know the answer for the first one, f of x plus delta x. I just found it here. Subtract from it f of x, which is what? 2x minus 3. Can we simplify that? What do you think the answer here is? 2 delta x, right? Because the 2x is going to cancel the 2x. The minus 3 is going to cancel the minus 3. What's step number 3? Take the answer from step number 2 and divide it by delta x. That's what this one says, divided by delta x. So I know the answer to step number 2. It's 2 delta x divided by delta x, and what's that answer? 2. And the last step, step number 4, you want to find the slope. You take the limit as delta x approaches 0 of the answer from step number 3. In some books, that's called the 4-step process because it requires 4 steps. So what's the limit as delta x approaches 0 of 2? And the limit of any constant is the constant. So what is the slope of this line? We know that's a 2. mx plus b. The way our book does it, if they want to find the derivative at 2, instead of using x here, they plug in a 2 directly. So that's how they do it. That's the difference between them and me. I'll mix and match. I'll do it both ways. I will do it where I'll be replacing x with 2, because usually if that answer has an x in it at the end, I go, wait a minute, they want the answer at 2. Let me let x be 2, and I'll get the answer. Just like the next example. And the book actually got smart here. Like it's going to use the way I'm doing it. Solve it for x there first, then plug in the value, because that's quicker. That's almost everyone does it that way. Same thing. F of x equals x squared plus 1. Find the slope of the tangent line. Of the tangent line. At a couple of times they want it. The first time at 0, 1, and another time they want it at minus 1, 2. Just curious about this. Trust me, I took the problem from the book. This one says find the slope of the graph. It didn't say of the tangent line. This one says the slope of the tangent line. Why? Why they left the word tangent line out of this?
Because that has 1 point, the other has 2.
Nope, that's just, they want the slope. I could ask you the slope at 2 and 1, 5 and 7, 12 and 13.
Tangent line's the same everywhere.
Exactly. This is a straight line, right? Straight line, the tangent line, and the actual line have the same slope. That's why they don't use the word, really, tangent line. This one, that's a parabola. The graph of this is a parabola concave upward. It looks like this. So the slope, it depends. The slope at 0, 1 is going to look like this. If I graphed it right, it should be the answer to this, should be 0. The slope at minus 1 and 2, somewhere here, should be a negative number. Because that tangent line is, notice, it's coming down. The slope of that should be negative. So if my graph is correct, the slope at this point, the slope at that point are different. And I'm going to do the 4 steps again. I don't have to graph these, but I'm just trying to explain what we're looking for. Step number 1, find f of x plus delta x. which is replace x with x plus delta x, square it, plus the 1. FOIL that out. X squared plus 2x delta x plus delta x squared plus the 1. I don't like delta x. A lot of math books, they use h in place of delta x, by the way. And if you don't like delta x because it's 2 letters, put h there. Doesn't make any difference. Step number 2. F of x plus delta x minus f of x. X squared, 2x delta x squared, plus the 1, that's the first part, minus the second part, x squared plus 1. The x squared is gone, the 1 is gone. So we end up with what? 2x delta x plus delta x squared. Step number 3. You want to take the answer from step number 2 and do what with it? Divide it by delta x. That'll be 2x delta x plus delta x squared. Divide that by delta x. Now you're dividing each one of these by delta x. So you're going to end up with what? 2x plus what? Delta x. And what's step number 4? Take the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. That'll be the limit as delta x approaches 0 of 2x plus delta x. Now replace delta x with 0, and what do you have? 2x. Now you want to find the slope at 0, 1, right? That's the first question. At 0, 1. So what is m at 0, 1? Go to that one. Replace x with 0. 2 times 0, which is what? 0. You want the slope at minus 1 comma 2. Go to that equation and replace x with what? Minus 1. You say, how about y? The equation doesn't have y in it. It has only x. That's a negative 2. So we know the slope at 0, 1 is 0. We know the slope at minus 1 and 2 is negative 2. So that's why I like to solve it for x first and plug in the numbers later, because I can answer any questions they give me.
How did you get the answer 2x out of that?
Delta x approaches 0, so you let delta x be direct substitution.
Oh,
You put 0 for this, you end up with that.
right.
Now, instead of calling the slope of the tangent line, that's a silly name, the slope of the tangent line. So guess what we're going to call it? Derivative. So you're going to hear me the word derivative. So the word derivative means the slope of the tangent line. It's just a change of name. So derivative will be the limit as delta x approaches 0 of f of x plus delta x minus f of x all divided by delta x. I'm not going to write the word derivative. Notice it's a big word to write every single time. So we have a shortcut for that. What do we use? F prime of x. That means the derivative. That's a common notation, f prime. Some people call it dy dx instead of delta y delta x. You know the slope is change in y over change of x, delta y over delta x. Once you put d instead of delta, that's an assumption in math that the gap is very small. Delta x approaches 0. So dy dx is a common practice for it. Some people call it y supreme. If you have y, they ask you for y supreme. So all of these means find the derivative. Find that. Some people write it d dx of f of x. Some people write it this way, capital D of x square bracket y. So all of these imply find the derivative. Do the 4 steps and find the answer to that. Yes?
Most common one that's used.
Most common probably out of the 4 of them, this is common, that's common. The first 3. Those are very common. You'll see me use them all the time. So if I have f of x equals, I'll say find f prime. If I had y equals, I'll probably say find y supreme or dy dx. Either way.
Most of us have the dy over dx.
Yep. Or y supreme. Especially on the newer books, because we don't want to type fractions, because you have to go to equation editor and type dy dx. We can go y and just go to superscript and put that hyphen there. So it makes it easier to write that. That's why these notations are very popular. So let's take a couple of examples on that. Finding the derivative. We're going to spend some time on this because this is really, I might even just do section 3.1 today and that's it. How long has this video been on? Forgot.
Doesn't matter anymore, does it?
Well, no, I don't like to win the long ones. People